right, good afternoon, everyone. Looks like we got some nice rainy weather coming up. I'm looking forward to that. At least not having to water my lawn for a few days. Just a reminder about the football game this weekend. Hopefully we don't get rained out too much for the game. And also, if you're interested, on September 26th, there's going to be a Game of Life reality simulation fair. That can be a really interesting thing to go through. Basically just walks you through a lot of different things that you're going to have to make decisions about over the course of your life. So if you have some time to check it out, definitely recommend that you do so. All right, so last class we started talking about multiple cash flow streams, right? And that's mostly what we're going to be dealing with throughout the rest of this class is evaluating those multiple cash flow streams. When we started out looking at time value, we started off with just a single future value or present value just because that's kind of the easier situation to start learning from. But in practice, usually we're dealing with a cash flow stream. Right? And so the method that we use to evaluate that cash flow stream is discounted cash flow analysis. Right? Basically just allocating cash flows to their appropriate time periods. Right? And if we follow these 4 steps, that's basically going to help us solve the vast majority of problems that we're going to be facing in this field. Right? We have to understand the time frame. We have to allocate our cash flows to their appropriate spot along that time frame. Then we discount or compound each cash flow within each year, and then sum up all those discounted or compounded cash flows. Same steps applicable to very many situations that we're going to be dealing with. Right? And we started working on problems, basically just doing that. Right? So, right, starting from the top, we set up our time periods, allocate the cash flows, get our discount factor, gets us to our present value, right? Remembering that the present value of any cash flow is just the future cash flow times the discount factor, which is where we got our present values in each year, add it all up for the total value of that cash flow stream. All right, so today we're going to keep talking about multiple cash flow streams, and we're going to be focused on 2 particular types cash flow streams that we're going to be dealing with. That's going to be annuities and perpetuities. Oh, question in the back. All right, so all PowerPoints are in content. Actually, let me switch over to the student view. Content, and under PowerPoints, and we're in Unit 2, present value, future value, multiple cash flows. Can you confirm that that's shown up on your end? Anyone else have it? Yeah? Okay, great. Yep, so PowerPoints are all listed under that section, and I hopefully have them all correctly allocated to the appropriate unit. And the Excel practice that we also work on in class is posted to D2L as well under course note. Any other questions before we get started? All right, so 2 particular types of cash flow streams that we're going to be dealing with pretty regularly are going to be a perpetuity and an annuity. All right, so when we're dealing with regular cash flow streams, the cash flow table method that we were looking at is going to be the best way to go about it. But there are going to be some more consistent cash flows that we're dealing with, in particular annuities and perpetuities, where there's a formula or a function that's also pretty easy to use. All right, so we're going to look at the contents of that. So those types of cash flows are going to be a perpetuity, which is a cash flow occurring forever. And this is something that we see relatively frequently, especially for valuation purposes when we're valuing a stock. Very often the perpetuity terminal value method is going to be used to value a company's stock. And there's also a lot of very often insurance side products that are going to be related to perpetuities that people might be interested in purchasing for a combination of for themselves, for kids, grandkids, someone else that they want to try to fund, an endowment that they want to help fund. All right, so those are very often going to be what annuities are going to be used for.
So when you say constant cash flow, what do you mean by that?
Constant cash flow means it's a fixed cash flow or growing at a fixed rate.
Okay.
Right? So this would, like a perpetuity, an example would be receiving $1,000 every month, every year, forever. Another version would be a growing perpetuity, which is an inflation indexed perpetuity. So it starts at $1,000 a month and grows by, say, 2% per year.
And you mean like it's adjusted to inflation?
Correct.
Okay.
Yes. Yeah, it goes up at some inflation level. Yeah. All right, and then there's an annuity, which is a cash flow over a specific amount of time, right? So it would be that $1,000 a month for say 25 years, right? So there's a cutoff to an annuities time period, right? And so one of the most common uses for that is something in retirement, right? Very often at the start of retirement, a retiree can purchase an annuity, and that will then just supplement their income, right? They'll transfer their assets in an account to an annuity portfolio, and that'll basically then pay them from interest in the account, or they'll just draw down their assets over time. All right, so these are two types of cash flows that we're going to be working with today. Perpetuity, cash flows occurring indefinitely. Annuity, cash flows occurring over a certain amount of time, keeping in mind that these are fixed cash flows are growing at a fixed rate. So a perpetuity, right? This is the one that's taking place indefinitely. It is also one of the simplest formulas that we're going to be dealing with in this class. So the way that we're going to be valuing a perpetuity is we just take the cash flow and divide it by the discount rate. Right, very straightforward. So right, if we have a discount rate of, let's say, actually I don't want to do any math in my head, I'm very tired. We'll see in a few minutes in Excel. It's one of those, I haven't been sleeping well for like months, and then this morning I was up at 3:30 and just, one of those times. So no mental math, but Excel will help us in a moment. The formula itself, though, is very straightforward, right? We have a fixed cash flow. You just divide that cash flow by the discount rate, and that's going to get you the value of the perpetuity. Then we have a growing perpetuity. This gets slightly more complicated, but it's just one more thing that we're adding to the perpetuity formula, and that's netting out the growth rate from the discount rate. All right, so G is going to be our growth rate. So if we have a growing perpetuity, so something like an inflation-indexed perpetuity, that's growing with the inflation rate over time, then we'll get the value of that cash flow stream by subtracting that growth rate from the discount rate and the denominator here. You can also note, right, if G is equal to 0, then the growing perpetuity formula just condenses down into the standard perpetuity. Any questions on perpetuities before we look at some?
So you said when it's growing perpetuity, you're subtracting the inflation?
You're subtracting the growth rate.
The growth.
Usually inflation is the growth rate that's used for perpetuities, but it's the growth rate of the perpetuity.
Can you repeat that again?
Yeah. So we're subtracting the growth rate from the discount rate. For perpetuities, that's very often, the growth rate is very often the inflation rate, but not necessarily. Yeah. So often, but not necessarily the inflation rate.
Like if you had to give a percent that when it is subtracted, like what percent would you say that it is?
Very often low growth rates, like 2 to 4%, maybe.
So not that often.
So what?
So not that often.
What do you mean by often?
Like when you say that the growth is connected to the inflation, is that what you said?
Kind of. So when someone purchases a perpetuity, they might have options for how much the cash flow is going to grow. Usually what they want the cash flow to grow by is the expected inflation rate. Right? So it's basically going to maintain the real purchasing power of the money that you're receiving from this investment. Right? So that's why I say that we're subtracting the growth rate of these cash flows, and it's often tied to the inflation rate, because that's usually what people want a growing perpetuity or an annuity for, is to just maintain purchasing power over the asset's life. Yeah. Right? Because as inflation increases, the same dollar buys less. Right? So the motivation for a lot of investors with growing annuities and perpetuities is maintaining their purchasing power from that investment.
So do you think, like, as inflation goes, do you think their investment is going to grow as well, or is going to like keep the same growth rate?
It depends on the product, right? There's going to be variable growth rate and fixed growth rate. So it depends what they had. Any other questions? All right. All right, let's take a look at a couple examples now. So let's say that we're going to purchase a perpetuity that pays out $10,000 every year. What is that perpetuity worth if the discount rate is 8.5%? All right, so all we're going to do here is take that cash flow and divide it by the discount rate. That gets us the value of the perpetuity. Right, so an example like this is if someone's endowing, say, a scholarship at a college, they want it to pay out $10,000 a year every year, they would have to invest about $117,000 in order to make that happen. And then that scholarship fund would be paying out $10,000 every year indefinitely. Right? This is one of the tools that are used to help fund scholarship programs at universities. We can also apply this to valuing a company stock if they happen to pay dividends. Typically, companies' dividends grow over time. They're not fixed. But let's just say that a company pays out $1.75 in dividend, and it's going to be growing at 7% a year. Or sorry, not growing. It's going to have a discount rate of 7%. The value of the stock would be $25. All right, so now we're going to add a growth rate here. Do you think the growth rate is going to increase or decrease the cost for these investments? Say it again.
Increase.
Increase. Yeah. Right. Mathematically, we're lowering the denominator. Economically, this growth that we're going to be adding to this cash flow stream is valuable. Right. If we're maintaining purchasing power, that's going to basically mean that the cash flows we're receiving from this asset over time are worth more. And so, as those future cash flows increase, we have to pay more today to have access to those cash flows. All right. So, if we want to keep up with inflation. All right, so say growing this $10,000 at 3%, we're going to use the growing perpetuity formula, which is the cash flow divided by the growth adjusted discount rate. So the 8.5% minus 3%. So it increased the cost or the value of the perpetuity from $117 to $181. All right, just a 3 percentage point growth that we're adding to this cash flow is adding, again, I can't do mental math, right? About $60,000. Right. So adding growth adds a significant amount of value. All right, so now we're going to see something that gets a little bit trickier. Can anyone point out the difference between these two problems? Take a second to read these problems and tell me what the difference is. Let me zoom in there a little more for you.
Is the 10,000 for this problem the current value, and then 10,000 in the previous one is like future value?
Yeah. Right. So basically, we're looking at a difference in timing. Right. So notice the wording here. So in the first example, this perpetuity pays out $10,000 starting next year, growing at 3%. And this one, the perpetuity just paid out $10,000, and it's going to continue growing at 3%. All right. So basically, what this is saying is that there's a 1-year time difference between the timing of this $10,000, and in that 1-year time period, there's going to be a 3% difference in the value of the cash flow being paid out. Right? Keep in mind, we're interested in valuing expected cash flows. So if a cash flow has already occurred, in this example, the $10,000 was already paid out, then we are only interested in that $10,000 insofar as it is used to project the next period's cash flow. So we're going to use this $10,000 to estimate what the next period's cash flow is, and from there we can get the value of the perpetuity. All right, so we need the next period's cash flow. How do you think we can go about finding that next period's cash flow?
Future value.
What's that?
Future value.
So that is one thing we can do. There's a slightly simpler step when we're just looking for a one-time period growth. Right, we were looking at this when we were looking at the growing cash flows last class. Technically, we can use the future value formula, but there's a slightly simpler approach in this example.
Do the growth rate.
Yeah. What do we have to do for that?
Multiply the current value times the percentage, the growth percentage.
All right, so careful here, right? If we just multiply it by the growth rate, it's telling us how much it's growing by. right? So in other words, over that year, the perpetuity increased its cash flow by $300. So there's one more step we have to make here to get the total perpetuity cash flow in the next year. What's that other step? What's that next step we have to take? We add the original amount, yeah. So an easier way to do that in Excel, we can take 1 plus the growth rate and multiply all that by the $10,000, right? Because now what we're doing is 1 plus anything is just itself. So we're keeping that initial $10,000 and then adding in that 3%. All right, so we're going to get the $10,300 as the next period's cash flow, like that formula is telling us. All right, so the timing of cash flows don't matter when we're dealing with an ordinary perpetuity because the cash flow stays constant over time. It doesn't change, so the timing doesn't matter. Timing does matter, though, when we're dealing with growing annuities or perpetuities because when a cash flow occurs is going to now have an effect on what information we need in our present value. All right, so in this case, $10,000 was paid out this year, means it's no longer relevant, but we can use it to project next year's cash flow, which is going to be $10,300. All right, from here, we just follow through the rest of the growing perpetuity formula. So we take the discount rate, subtract out the growth rate, and we've added about $6,000 in value just by shifting the perpetuity cash flow back by 1 year. All right, so just a 1 year shift in the timing of the cash flow adds $6,000 in value to this perpetuity. Let's look at what happens, again, to that dividend-paying stock if we just add in a 2% growth rate. So is expected to pay $1.75 every year. So that means, right, next year, it's going to start paying this cash flow. So we don't need to make any adjustments. And we'll take the growth-adjusted discount rate for the value of $35, right? $10 more than that original $25 per share. Any questions on perpetuities? Yes.
Can you do that one you just did one more time?
Yeah. Right, so, right, the value of a perpetuity is the next period's cash flow divided by the growth-adjusted discount rate. And this question is giving us that next period's cash flow, right? The $1.75 is starting next year. So we're going to take that $1.75, divide it by the discount rate minus the growth rate. That'll get us the $35 value. Any other questions? All right. Now we're going to be looking at annuities. So an annuity is a cash flow that occurs over a fixed amount of time. All right, so whereas perpetuity goes on indefinitely, annuity is for a specific time period. So we do have a formula for this. In my personal opinion, you don't have to bother memorizing the annuity formulas. I do recommend you memorize the perpetuity formula. We'll be using that pretty frequently. The annuity formula, there's a lot going on there. And very often we'll either be using the time value function in Excel or a cash flow table rather than the annuity formula. We'll be doing a couple examples with it today, but I definitely recommend using a cash flow table or the Excel function rather than this formula.
Is annuity used more like when you're trying to get like a house loan?
I mean, I guess in a way you can think of a loan. No. So in terms of its structure, I guess it's similar, right? You're paying the mortgage amount over a fixed amount of time, but it's inverse, right? You're paying that cash flow to someone else. And in an annuity's case, you're receiving that money.
Okay.
But structured as a time value problem, it's very similar. Yeah. Right, so we do have the formulas for present and future value annuities, but again, cash flow table and the time value function in Excel, I definitely recommend using those instead. All right, so this is basically what we already started working on with the cash flow table problem, right? So we're just gonna repeat this example real quick, and we'll also use the annuity formula and the annuity function just so you can see going through the process using those different steps. All right, so again, the process of establishing your time period, step number 1. Step number 2, allocate your cash flows. $100 over the 5 years. Set up your discount factor, 1 plus the discount rate, fixing reference to the discount rate raised to the year that you're in. All right, and what should happen to the discount factor as we copy it forward into the future? Should we expect it to increase or decrease? What is it? Decrease. Yeah. The further we receive our cash flow in the future, the less it's going to be worth today. And that's exactly what we're seeing. Teams is always asking for stuff, and I never use it. All right, so our discount factor is declining the further into the future that we go. In other words, it's saying that the present value is worth less the further in the future we receive this cash flow. Everything else equal, that's going to be the case. Whoops. So we have our present values in the last step, sum it all up. All right. Now we'll replicate this using the annuity formula. I have that posted right here because if I didn't have it posted right there, I would forget a parenthesis somewhere. I might still miss a parenthesis. We'll see. So we've got 1 minus 1 divided by 1 plus the discount rate raised to the number of years, close parenthesis, and divided by discount rate. If it's not $3.99, oh, thank goodness. I don't like when I mess those up. It's always a hassle to figure out where I missed a parenthesis. All right, but that's part of the reason why I'd recommend using the other methods. All right, with the cash flow table, it's very concrete where you're putting the information in if you're messing something up, right? Every single step should make sense and should comport with the problem that you're working on. Right, so if we put $200 instead of $100, very quick fix, and we can readily see, oh, we put the wrong number in there. If our discount rate isn't steadily declining across time, we messed up the discount factor because, right, we should expect it to be declining over time. Right, and when we're multiplying the discount factor times the cash flow, we should similarly see that present value is declining over time if we have that fixed cash flow. And last step, sum it all up, relatively easy. When we move to the annuity formula, right, we don't have a disaggregated view of the problem that we're working on. So if you mess something up, you might have to just go back and restart the whole thing. You got to go through line by line, just double checking that things line up. So I do recommend avoiding the formula. Or if it's something you want to practice, if you're going to sit for right, something like the CFA exam, you should memorize it. But otherwise, using the cash flow table or the annuity function is going to be easier or more informative. So the annuity function, when we have a constant cash flow, this is going to be the easiest method for calculating it. That's just going to be the present value function. We need the rate, number of periods, and the payment. So 3 different methods to get the same answer. There's pros and cons to each one of them. The cash flow table is the most informative. We'll be relying on it a lot more at the end of the semester when we start dealing with more complicated cash flows and putting together those cash flows. The annuity formula, Right, this is something that you can memorize and throw straight into a calculator without needing any more complicated software like a financial calculator. But it is fairly burdensome to make sure that you're not messing anything up in it. And lastly, the annuity function. If you're dealing with a straight cash flow, it's the easiest method, least amount of time to put that together. Any questions so far?
Professor, can you go back to the discount factor part?
Mhm.
Oh, yeah.
Be equals 1 divided by, open parenthesis, 1 plus the discount rate, or 8%, close parenthesis, raised to the year that it's in this case, 1. All right, and I'm fixing reference to that 8% because the discount rate isn't changing over time.
Thank you.
Yep, yep.
Can you go back to the 137 and see that?
The annuity formula.
Yes.
All right, so that's going to be the cash flow times open two parentheses, 1 minus 1 divided by our discount factor, or 1 plus the discount rate, close parenthesis, raised to the year, close another parenthesis, divided by the discount rate. Any other questions?
Is that 1 minus 1?
Yes, but under that minus 1, it's divided by 1 plus the discount rate. So it's basically the discount factor that we're dealing with in there. So back to formula. All right, this is what we're calculating there. So it's 1 minus 1 divided by 1 plus r to the end. But yeah, in the numerator it is that 1 minus 1 section. Any other questions?
Could you go back to the equations briefly on the slide?
Oh, in the slide? Yeah. All right, we're going to keep working on a couple of problems. Now we're going to go in the opposite time direction. Now we're going to look at a future value, but same method, only difference is we're taking the compounding factor rather than the discount factor. Right, very similar to what we were working on last time, but we're also just going to do an example with the formula and the function again, just so we can see how that's working. All right, so now we're going to be saving up $2,000 every year. So we got our time periods, we've got our cash flows, now we got to get our compounding factor. That's going to be 1 plus our growth rate. This is raised to how long we're saving up for, right? Which is going to be the last year minus the current year. Can anyone remind me why I'm taking the last year minus the first year here, or the current year? Exactly, right? So in time value, we're always we're generally assuming that cash flows occur at the end of the time period, right? So if this $2,000 occurs at the end of year 1, we save it up at the end of the year. That means it has 1, 2, 3, 4 years to grow. So that's why we're taking the difference between the last year and the present year. It's how many years we're compounding by. So inverse to the discount factor, we should see the compounding factor increase as we go back in time. Actually, I guess it's similar to the discount factor in that it's declining across time. But the basic idea here is we're declining toward 1, not toward 0. right? Because in that last year when we save up the $2,000, it's just going to be worth itself. It doesn't have time to compound. So now we'll multiply our cash flow times our compounding factor, sum all that up. And so we've saved up $10,000, but because of the 6% interest that we're earning, the total value at the end of this time period is going to be $11,200.
Using Excel, how did you sum? You just put equal sum and then copy all of them.
Yeah. So equal sum. If I hit tab, that'll now open up the parenthesis and get Excel to copy all the information. Then I just use the arrow key to hold down Shift, highlight these values. I could also hit Control Shift to highlight the entire row. It basically, when you hold Control Shift, that'll highlight everything within the range. So I hit Control Shift, then Enter. And very often Excel will assume when you're using a function, if you don't end with a parenthesis and you hit Enter anyway, it'll usually assume that you intended to hit a parenthesis. So it closed up the parenthesis for me there. Yes?
Can you click on one of the compounding factors?
Yeah. It's equal to 1 plus the compounding rate, fixing reference there, raised to the difference between the last year, 5 years from now, and fixing reference there, minus the current year.
Like remember, do we have to put the dollar sign in ourselves? How do we do that?
So what are you on? HP? So on Windows, you hit F4 to fix reference, right? So you can manually put in the dollar sign in front of the column and the row, but alternatively, you could just highlight the cell you want to fix and hit F4. Right? So in the workspace here that you're typing into, highlight the cell you're interested in fixing reference to and hit F4.
And then the format for the compounding factor, you have that in general.
Yeah. So a good way to split up the formatting is if you're dealing with the dollar value, use currency. If you're dealing with a percentage, use percentage, right? Usually a good idea to keep it a couple decimal points out, so if it was 6.5%, you'd see that. And if you're just using a typical number, then general format is usually the best way to go. Any other questions? All right. Now we're gonna work through another annuity formula example. So that's gonna be our cash flow and multiplied by, I think we need 3 parentheses just to be safe. Then 1 plus our discount or compounding rate, raised, close parenthesis, and raise that to the number of years, minus 1, close parenthesis, divide by the rate, again, close parenthesis. And when you're working with so many parentheses in Excel, if you look at it closely, the parentheses are going to be color-coded. That's to try to help you see where exactly the brackets are breaking the numbers up, right? So I think this is purple. This purple bracket is showing us that it's enclosing the 1 plus the discount rate here. Then the second outer bracket, the red one, is enclosing that first parenthesis in addition to the minus 1. And then that third bracket in black is going to be the total fraction of these values with the discount rate. Hopefully yep, we got it correct. All right, so again, we should get the same answer using any one of these 3 methods. Right, there's just pros and cons to each one of these different methods. All right, lastly, we'll use the function. We're going to be calculating a future value. So we've got the rate, number of periods, and the cash flow. I'm going to do something wrong here. What am I doing wrong?
Negative.
Right, where do I need to put the negative?
C169.
Yes, in other words, the cash flow. There we go. All right, so again, 3 different methods, pros and cons to each. So what do we want to generally use the cash flow table for?
Was they figuring out value for over a couple of years?
Yes. In general, that's what we can do with all these, right? So what is the specific benefit for using a cash flow table relative to these other two methods that we're looking at?
How much is each year?
More data.
More data? Yeah, we have more information that's right there. Makes it a lot easier to evaluate if we do something wrong. And it also gives us just more information on what's driving the bottom line answer that we're getting. It's telling us what's coming from the cash flow, the compounding rate, that sort of thing. And there's one other benefit. I saw your hand over here.
Oh, I was gonna say that finding mistakes.
Finding mistakes. Yeah. Yep. That broadly, I think that might fit under what I was talking about. Maybe not. I guess depends how you define it. And then there's one other benefit here for the cash flow table that the other two methods can't. What's that?
Less parentheses where you can mess up.
Yeah, actually, now that we're talking about this out loud, maybe there's more benefits than I had originally thought. Okay. So the thing I'm trying to get at, though, is it can handle irregular cash flows, which we haven't really seen yet. Yes.
So I wasn't able to get the future value for any of those methods.
Okay.
I just can't figure out the formula for it.
Okay. I can look through your formulas after class and just kind of figure out what's going on wrong there. If there's a specific part you want me to repeat, I can do that though. But if you need me to look through, I can look at your workbook after class.
What's the formula for the first one?
For the answer, it's just summing up all the present values. And to get the present value, I'm multiplying the compounding factor by the cash flow. And to get the compounding factor, it's 1 plus the compounding rate, the 6%, raised to the number of years that it's compounding by, which is the last year, minus the current year. All right, so one thing we haven't seen yet is very irregular cash flows, which we'll be seeing more of later on in this course. So that's going to be maybe the last benefit. Do you have any other suggestions on other benefits for the cash flow table that maybe I haven't considered? I can argue more for this method in the future. All right. We have the formula method. The only benefit that I can think of for this is you can use it in any calculator. It's more onerous. It's much easier to mess up than the other methods. And it can take more time if you don't already have it set up to just copy and paste with information. Then the last method, the annuity function. This is the easiest method, right? I use it very frequently when just putting together like basic time value stuff for my own financial planning. But it's not going to be good for handling growth rates or any irregular cash flows in general. All right, so different pros and cons to each of these. Out of them, I definitely favor the cash flow table. We'll be using this throughout the semester. We'll use the function when it benefits us. After we do some more examples with the annuities formulas, we're not going to be using that again. But I feel obligated to show it because everyone else does and don't want to hamstring you there. Any other questions? All right. All right, we'll just do, I think, one question with the growth rate. I'll probably just delete these, save some time working on them. All right, so let's say that we're trying to figure out the value of an asset. It's going to pay out $1,000 in the first year. It's going to grow at 5% for 3 years, and the discount rate is 8.5%. All right, so well, I've already laid out the years here, but can anyone walk me through how I got 4 years total here that we're going to be dealing with?
You start off with 1,000 for the first year and then 3 additional years after that.
What are those 3 additional years for? What's that? Growth, yeah. All right, so we start off with our nominal value, the $1,000. And from there, we're going to be growing. And that's going to be the previous year times 1 plus the growth rate of 5%. Now be very careful here, right? We're starting again to deal with multiple cash growth rates. So you want to be careful in what you're referencing. the growth rate is 5%, the discount rate is 8.5%, right? And those are two different functions. The growth rate is affecting the cash value. The discount rate is affecting the time value. Right? And the total present value today is the combination of cash flows and time value. So now we're going to get our discount factor. 1 divided by 1 plus the discount rate raised to the year. And again, this should be declining across time. That's what we're seeing. Now we should get the present value, which is the cash flow times the discount factor. Carry that forward. And the total value, sum it all up. So the total value for this cash flow stream is $3,500. So translated into action, what is this value telling us? If we're thinking about purchasing access to this cash flow stream?
The value of the asset.
Mm-hmm. Yeah. How do we use that information?
Whether or not we should pay for it.
Right. Right. In other words, we should be willing to pay up to $3,512 to have access to this cash flow stream. All right, that's basically what we're dealing with present values. We're trying to figure out how much is something worth, and that tells us how much we should be willing to pay for it. All right. Now we're going to go through this mess over here to use the annuity formula. Maybe I should just take this out in future classes. I hate using the formula. I imagine you guys would hate it even more. All right, so we're going to use our annuity formula here to hopefully end up with $3,500. All right, so we're going to take our cash flow, open up a couple parentheses there to get this going. 1 minus 3 whole parentheses. 1 plus the growth rate, closing 2 parentheses, divided by, again, opening 2 parentheses. 1 plus our discount rate, closing 3, yep, and raised to total number of years. That might be wrong. We're about to find out. Divided by the adjusted discount rate. Oh, that's so wrong.
The growth rate instead of, or growth rate instead of discount rate.
Where?
I think you just fixed it.
There. Let's see. Not letting me hit enter, so I did. Oh, there we go. Okay. Yeah, thank you. All right, so I accidentally used the discount rate instead of the growth rate. All right, so as you can see by what I just set up, very easy to mess up if you don't set it up correctly the first time. It can be a problem to figure out where you went wrong. And again, it gets you the correct answer, but it lacks the informativeness of the cash flow table. You can't see what's going on explicitly, and that's going to be very valuable when you're considering really making some sort of investment decision. All right, so I'm just going to go ahead and we'll. Does anyone want to see some more examples using this? I'll go over them if anyone does. Otherwise, go to bed. Yes.
Can you go over the discount factor for 175 through
1. So
that problem?
the one I'm highlighting? Okay. Yep. 1 divided by 1 plus the 8.5% discount rate raised to the year that it's in. Any other questions?
And can you use the annuity function for that same problem? No.
The function is specifically for fixed cash flows. Yep. I should actually look. There's probably an Excel added by now that would do a growth rate as well, but the base time value functions don't.
During the quiz at home, will you give us the formulas?
You can use whatever you want.
Okay.
So I definitely recommend using Excel. Right, that's what we're using in class. You can use it to answer the problems for all the assignments as well. Any other questions? All right. Go ahead and take that out. We got through. So one thing to keep in mind is the timing of the cash flow. So we already saw this example earlier when we were looking at the timing of the cash flows, right? Well, 1 year difference in compounding can result in significantly differences in value, right? So we saw a $6,000 difference in the value of this perpetuity just by moving the 10,000 cash flow earlier, which in essence is just $300. Right? $300 in additional value paid out in the next year is resulting in the value of this perpetuity increasing $6,000. Just because that infinite compounding is occurring just slightly sooner. Right? So the timing really matters when we're dealing with time value, especially in perpetuity. Right? So the value of any asset is going to change depending on when the cash flows the asset is generating occurs. Right? So in general, whenever you receive a cash flow earlier, the higher the value of the cash flow stream is going to be. So, like most time value problems that we work on, annuities assume cash flows take place at the end of the year. Again, usually annual increments. An annuity due is when a cash flow takes place at the start of a time period. Right, so we have to make an adjustment to reflect that timing. It's basically the equivalent to just an additional year of interest. Right, so if you're looking at the formula, if you're looking at the present value, you literally just add in another cash flow, and for the future value, you add in an additional year of compounding. So I think we can stop with our examples for today and pick up next time talking about compounding. Are there any questions before we get going?
So on quiz 1, that kind of question will be there?
Probably. It's randomly generated for every person, but it's going to be in the question pool. So I do recommend don't start the quiz until you've done all the homework. Use all 3 of your attempts before starting the quiz. And you still have, 12 days until it's due?
Right.
So plenty of time to work through the homework assignments. And I do recommend doing at least one homework for Unit 2 before starting Quiz 1. There's some bleed over in information, and the more you practice, the better it's going to go overall. But like I mentioned last class, if you haven't started the homework already, definitely recommend at least getting in 1 or 2 attempts at this point. You still have some time until it's due, but give yourself time to practice those assignments. Yes?
After today, we're ready for like chapter 2 homework?
Maybe start 1.
Okay.
Maybe use 1 attempt for chapter 2, but I would wait until after at least Tuesday next week to really work on this.
Do we need the annuity and annuity due formulas? They're not in the PowerPoint.
I'm still like on the last 3.
You gotta download it. It's not gonna show up in
I was wondering why, because I was downloading.
Yeah, that's what you gotta do.
Yeah, I didn't see the annuity due on the formula sheet.
Oh, on the formula sheet in D2L?
Yeah, I didn't see it on the PowerPoint or the formula sheet. I may have just not seen it.
So are you only looking at it in D2L?
Yes.
Okay, that's the problem. A lot of formulas don't show up correctly in D2L, so you have to download the sheets to view them.
Class is over.
If I start,
We watched both lectures.
Not sure if that has any relevance.
pardon?
Do you have a bank account here?
I want to be doing
You
this.
should be able to open up a bank account then, I would guess. Who do you bank with? Okay, so I do as well. They own Merrill Lynch. That's a brokerage company. So maybe schedule an appointment with your baker that you want to open up a brokerage account and help you get started with that. But just make sure that they're disclosing any costs associated with it. It should be free to open up a brokerage account and transfer money in there from your Bank of America account.
Thank you.
So this is the.
I like that.
He said, I gotta go home.
Oh, that's why. So
All correct.
we're dealing with a cash flow stream.
It is.
So
So I think it's
the cash flow that you're referencing, if you highlight the time value function, can you highlight the? No, it's not. Not showing. Oh yeah, there we go. There we go. Not showing what we need. Right, so it needs the rate, the number of periods. So we're dealing with the payment.
Yeah.
The payment is a reoccurring cash flow. Right, so what you did when you put that additional comma in there, you're referencing the present value as a single cash flow stream rather than, or a single cash flow rather than reoccurring cash flow. Right. Because it's a reoccurring cash flow. It's occurring over multiple time periods.
From communication, but I didn't know for sure.
most of my classes like it's at least one person I'll see every day.
Yeah, it's because we're getting into the core stuff. We're all gonna start seeing each other.
You're going about it correctly.
For sure.
Oh, it was already, okay.
So it's the rate.
God, is it raining still?
Yes. It's worse right now in Memphis. Like they tell their they can like all the schools out and tell them come get your kids by 12:30.
Oh, that's lovely. Wow.
They say like trees are falling down, and it's on our way. So
It was storming in Nashville earlier, but
It considers.
calmed down a little bit.
yeah.
Right. Right. Keep in mind the difference, right? Payments are the real cash flows, which is what's happening in this example. What we started
Yeah, I
out
saw someone
this
just
single
get like demolished last semester by a tree. I was like, man, I'd hate to be that guy.
Really? That
Yeah.
sucks.
The tree went through the engine.
Oh my god.
Yeah.